of the class. Okay. So do you have any question about exam? Or do you have any other question?
Concerns about my judgment.
Okay. So we'll try to go over all the review problems, but we have just one review class. So I think we cannot finish all the review problems in today's class. So what I'm planning to do, we'll try to complete as many problems as we can. And I will do an extra review class. So which I will record on Saturday, I think. And I'll send you the Zoom link. So that class is optional. So if you want, if you'd like to attend, and if you are available, then you can attend. Otherwise, you can see the recorded class on YouTube. So I will post it on YouTube and send you the link. Okay. No, you do not have to get 100% to get an extra credit. So if you get at least 80%, I'll give you 10 point extra credits. And if you get more than 50%, then you will get at least 6 to 7 points extra credits. If you get at least 50% correct. Okay. I do not expect that you will get 100% correct. So if you get at least 70 to 80%, yeah, then okay, so I'll make it 70%. So if you get 70% correct, I'll give you 10 point extra credit. Okay, that sounds good. Okay, so is there a way to calculate sample standard deviation without an advanced calculator? Okay, so you can use the spreadsheet, then you do not need a calculator. So you can do everything on a spreadsheet, Excel sheet, okay? So you can find the critical value, you can find the p-value, you can find everything on Excel sheet. You can calculate the mean, you can calculate standard deviation. Yeah. Or if you do not have advanced calculator, you can also use online calculator. Okay, so any other question? Okay, so if you do not have any other question, then we'll move to the review problems. Complete parts A through E from the population data. So this data is population data 2, 4, 6, 8. So we need to find the mean. Since this data is population data, so the mean will be then you have to add all the numbers, then 2 plus 4 plus 6 plus 8 and divided by 4. So that will be the mean. So then it will be 2 plus 4. So 2 plus 4 plus 6 plus 8 and divided by 4. So it will be 5. So the answer for this question will be 5. Mu is 5 here. So this is 5. And let's check the answer. Yeah, that's correct. And second part is for each of the possible sample size, construct a table with all possible samples and their sample means. So you will construct all possible samples and their sample means and draw a dot plot for the sampling distribution of the sample mean and find the sample mean X bar for each possible sample of size n equals to n. So here are the sample size is n equal 1. So that means you will just consider one number from 2, 4, 6, 8. So the first sample is 2, the average will be 2, right? And this is 4, so the average will be 4. So the first number will be 2, and this number will be 4, and this number will be 6, and this number is 8. Okay, so draw the dot plot for the sampling distribution. So we have the sampling data, we have X bar. Now we need to construct the dot plot for this one. So what will be the dot plot? So 2, we have just one number. So that's why we have one dot. At 4, we have one number, one dot at 6. So it will be this one. Yes, the next one is the sampling distribution. You have to calculate the sample mean for sample size 2. So we have sample size 2. The sample mean for the first sample, this is 2 and 4. So the sample mean will be then 2 plus 4, 6 divided by 2. So it will be 3. And this one will be 4. 6 plus 2 divided by 2 is 4. And this one will be 5. And this one will be 5 as well. And this one is 8 plus 4, 12 divided by 2, 6. So this is 14 divided by 2. So it will be 7. Yeah. So draw the dot plot of the sampling distribution. Now you need to construct the dot plot of this sampling distribution. So at 3, we have just one number, but at 2, we do not have any number. So this is not correct. At 3, we have 1. At 4, how many 4s we have? We have just one 4, so one dot. So how many 5 we have? We have 2 5s, so 2 dots. That's correct. So 6, we have one dot, and 7, we have also one dot. So that means this is the correct answer.
Take this. I'm on hold with the DMV. Some mix up switching my license registration. See how to take care of it.
Okay, so now you need to construct the sampling distribution for sample size 3. So the sampling distribution will be here. This is 10 plus 2, 12 divided by 3. It will be 4. And this one is 8 plus 4, 12 plus 2, 14 divided by 3. So it will be 14 divided by 3. So it will be 4.67, 2 decimal places. So it will be 4.67. And this one will be 14 plus 2, 16 over 3. So this is 16 divided by 3. So it will be 5.33. So this one will be 5.33. And this one will be 6. So that's the, so let's check the answer. Yeah, that's correct. So we need to construct the dot plot. So we have 4, 4.67, 5.33, and 6. So that's mean this is not correct. So we have 4, 4.67. Yeah, at 4.67 we have one dot. 5.33 we have one dot. At 6 we have one dot. So this one will be the correct answer. Yeah, now we have to construct the sampling distribution for sample size 4. So since sample size 4, the mean will be then 2 plus 4 plus 6 plus 8 and divided by 4. So it will be, the mean will be then 5. X bar will be then 5. Yeah, that's correct. And the dot plot will be at 5. We have just one number. So this one is the correct answer. Yeah. Okay, so use the dot plot from part B to create the dot plot with sampling distribution for each sample size. So now we will you will combine all the figures and you will just have one figure. So that's means when sample size n equals to 1, we have 4 numbers. So this is not correct. This is not correct. So the correct answer will be then this one, the last one. Yeah, this is the correct answer. Okay, so interpret the plot, choose the correct answer below. As the sample size increases, so what we can see from this plot, when the sample size increases, the variability decreases, right? So as the sample size increases, there are more possible distinct sample. That's not correct. As the sample size decreases, the sampling distribution of the sample mean clusters closer to the population mean. Yeah, that's what happened. So they clustered around the population mean. So this is this one should be the correct answer. Oops, this is not correct. The sample mean cluster closer to the population mean. The sampling distribution of the sample mean clusters closer to the samples. Oh, sorry, sample size increases. So I say decreases. It should be sample size increases. Yeah, so that's correct. Actually, this question has how many pairs? Okay. So per D, for each of the possible sample size, find the probability that the sample mean will equal to the population mean. So what is the probability for the first one? The sample mean is equal. So we do not have any number which is equal to the population mean, right? The population mean is 5. So that's mean for the first one, this is 0, right? The probability is, this is 0. And for the second one, you can see here how many numbers we have which is equal to 5. We have 2. So out of 6 numbers, we have 2 which is equal to, so that's mean it will be 2 divided by 6. The probability will be then 0.33. Type integer or simplified fraction. 0.33 means 1/3. Yeah. And number 3 is how many numbers we have which is equal to 5. We do not have any number, so it will be 0. And when n equals to 4, the probability will be 1, because we have just one number and which is equal to population mean. So that's mean the probability is 1/1. Yeah, that's okay. So for each of the sample size, find the probability that sampling error made in estimating the population mean by the sample mean will be 0.5 or less. So that's mean you have to consider, you have to do what you have to do. So the population mean is 5. So 5, that we can make error 0.5. So 5 plus 0.5 and 5 minus 0.5. So this will be then 4.5 and this one is 5.5. So you have to see like how many numbers are between these two numbers. So in the first one, this is 4 and this is 6. So there is no number. So for the first one, the probability is still 0, right? Yeah, the probability is 0 for the first one. Yeah, this one will be 0. And for that, for the second one, it is still 2/, so it will be same. So it will be 1/3. And for this one, how many numbers are between 4.5 and 5.5? I think we can see this per. Yeah, this is 4.67, which is within 4.5 and 5.5, and we have 5.33, which is also within. Okay, so this is we are looking at the. Yeah, so we have 2 numbers. Yeah, so for this one, we have 2 numbers which are within 4.5 and 5.5. So that's mean it will be 2/4. So 1/2. And the last one is, this is still 1. Okay, so let's check that. Yeah, that's correct. Okay, so do you have any question? Now, you do not have any quiz today. Okay, so I will post the recorded lecture on YouTube, and I will also post the link on Blackboard. And I will also email you the link, okay? So that you do not miss it. Okay, so this question is, each year a magazine publishes a list of the richest people in a country. So in the last year's issue, the 6 richest people and their wealth are as shown in the following table. So consider the 6 people a population of interest and complete pairs through A through E. So calculate the mean wealth. So we have the data. So you have to just calculate the mean. So let me clear the screen. Okay, so we have the data. You have to just calculate the mean average of this. Okay. And I'm not going to do this one. So I'm just putting a random number. This number is not correct. So you have to calculate it and put the correct number, because I want to move a little faster. Yeah. Okay, so the next thing is for sample of size 2. So you have to calculate the sample mean for each one. So that's mean you have to calculate the sample mean for this one, sample mean for this one, sample mean for this one, and you have to put this number in the box. So you have to calculate the sample mean for each one. Okay. And I'm not going to do that here now because it will take time. So you have to calculate the sample mean for each one. Okay, so we'll move to the next part. So how do we move to the next part? We don't do. So we need to put a number. So I'm just putting 5, 5 everywhere because otherwise we cannot move. I'm just putting, I'm sorry, 5, 5, 5. I'm just putting this number to move faster because I do not want to spend more time on this. This is just, you will add these two numbers, is 2 number and divide by 2. Yeah, okay. So this is not correct. Okay, so draw the dot plot of the sampling distribution of the sample mean. So now we have the correct answer here. So this is 67.5 and this is 55.5. So you have to construct the dot plot. So how many numbers do you have? We have 2, 4, 5. And here we have 5. So we have total 15 numbers. So in the first one, we do not have 15 numbers. So this is not correct. Here we do not have 15 numbers. So this is not correct. So now we have to check these two. Okay, you can see at 35, we have 2 numbers here, but do we have 2 numbers at 35 here? No, we do not have. Oh yeah, I think we have 2 numbers at, yeah, 34.5, 34.5. Okay, and at 49, we have also 2 numbers here. And at 39, we have also 2 number, 36.5, 36.5, 34.5, we have 2. Okay, and look at this one, we have this number. So the difference is only, this is very close, and this is 3, this is. Okay, so let me check this one. This is not correct. So this one is the correct answer. Okay. So the idea is this is 67.5. So at 67.5, you will have 1 dot. So this is the dot at 67.5. And at 55.5, you have also 1 dot. So at 55.5, you have 1 dot. So you have to just check this one, okay? So for a random sample of size 2, what is the chance that the sample mean will equal to the population mean? So what is the chance that, so what is population mean? Population mean is 47. So here population mean is 47. So how many numbers are equal to 47? So there is no number which is equal to 47. So that's mean the probability is 0, right? So let me check the answer. Yeah, the probability is 0. Okay, so for a random sample of size 2, determine the probability that the mean wealth of the 2 people obtained will be within 3 of the population mean. So within 3 billion of the population mean. So that's mean population mean is 47. So 47 minus 3 is 44, and 47 plus 3 is 50, right? So you have to see how many numbers are between 44 and 50. So how many numbers are between 44 and 50? So we have, I think, 1 number, 44 and 50. We have just this number, 48.5. Do we have any other number which is between 44 and 50? No, just 1 number. So out of 15, we have just 1 number. So it will be then to 3 decimal places. So it will be 1/15. So that's means 0.067. So this probability will be then 0.067. Yeah, that's correct answer. Okay, so here we have to determine the population mean. So we have the data here. we have to find the population mean. So you have to just calculate the mean. So we have 33. So it will be then 33 plus 49 plus 30 plus 35 plus 25 and divided by 5. So it will be then 34.4. So the population mean is 34.4. So this is the population mean.
Just to make sure.
Okay, the next one is consider sample of size 2. So we have to consider the sample of size 2, and we calculated all the mean here. So we calculated all the mean. So the mean of the variable x bar. So now we have the data for x bar. So we have the data for x bar. So this is the data for x bar. So you have to calculate the population mean for x bar. So that's mean mu x bar. So that will be actually, you have to add all these numbers and divided by how many numbers you have, 1, 2, 3, 4, 5, and here we have 5. So you have to, this is the total or sum of these numbers and divided by 10. So that will be the mean. Okay. So let me clear the screen.
That's absurd.
Okay, so I'm not going to calculate this. I'm just putting a number 0. This is actually a wrong number because I want to move further. So because without putting any number, we cannot move forward. Okay, so the mean is 34.40. So that is equal to this population mean, right? So find the mu x bar using only the result of part A. So what do we know about, so if population mean mu is 34.4. So for example, we do not have this information. We do not have this. So how do we find this mean mu x bar? We know that mu x bar is mu, right? So this will be also then 34.4. So that's mean this will be, this is 34.4. So this mean is 34.4. Okay. So identify the distribution of x bar. So a variable of a population is normally distributed. So it is given that the population distribution is normal distribution with mean mu. So the mean is mu and the standard deviation is sigma. So we have to find the distribution of x bar. So what do we know about the distribution of x bar? So we know that mu x bar is mu and sigma x bar is sigma over square root of n. So since the population distribution is normal distribution, so the distribution of x bar will be also normal distribution with mean mu and standard deviation sigma over square root of n. So that's mean it will be then normal distribution with mean mu and standard deviation sigma over n, with mean mu and standard deviation sigma over square root of n. So this is the correct answer. Yeah. Okay, so does your answer to part A depend on the sample size? Explain your answer. No, because the variable under consideration is normally distributed. Okay, so it doesn't depend on the sample size, right? So whatever is the sample size, it doesn't matter. Why it doesn't matter? Because the population distribution is normal distribution. So that's why it doesn't matter. So no, because the variable under consideration is normally distributed, right? Because it is given the population distribution is normal distribution. So the sampling distribution doesn't really depend on the sample size here. Okay. So the next part is identify the mean and standard deviation of x bar. So we already have the mean and standard deviation, right? This is mu and sigma over square root of n. So the answer should be this one. Yes. Okay. So does your answer to part C depend on the assumption that the variable under consideration is normal? Yes, it depends, right? Because based on this, we answered that the population, the sampling distribution is normal distribution. Yes, if the distribution x bar is skewed, the mean of X bar will be different from mu in the direction that the distribution of X is skewed. Yes, from some distribution X bar, the mean is no. So this is the correct answer. Oops. No. So does your answer to part C? I'm sorry. Part C, we are not determining the distribution, right? So we are just calculating the mean and sigma over standard deviation. So it doesn't depend on the distribution. So no, for any variable, the mean X bar, I thought that this question is asking about the shape of the distribution, about the normality. So no, for any variable, the mean X bar is at least approximately equal to mu, the mean X bar, yeah. So this one.
So we're clear.
And the standard deviation X bar is at least approximately. Any variable, the mean X bar is at least approximately equal to mu, and the standard deviation of X bar is exactly equals to mu. Both of them should be equals to mu and sigma over square root of n. Okay, so let me check. Yeah. Okay, so here determine the sampling distribution of the sample mean of sample size 3. So here the sample size n is 3. So n is 3. And let me read the question. The mean mu is 1.40. I'm sorry, the mean mu is 1.40 and the standard deviation sigma is 0.15. So use the data to answer the questions from A to E. So first we need to find the mu X bar. So what do we need mu X bar? This is equal to mu. So that's mean this one will be then 1.4, right? Because we found this is 1.4. So this is 1.4. Yeah, next part is find the sigma X bar. And we know that sigma X bar is sigma over square root of n. So what is the sigma value here? Sigma value is 0.15 and n is 3. So that means this will be 0.15 divided by a square root of 3. So it will be then 0.0867. So around 4 decimal places. So it will be 0.0867. Okay, so that's not correct. The standard deviation is, okay, so let me do it again. So sigma X bar, we know that this is sigma over a square root of n. So 0.15 over a square root of, the sample size is 3, a square root of 3. So it should be 0.15 over a square root of 3. Oh, okay, so 4 decimal places. So it will be actually not 67. So it's, I did mistake here. It should be 0.066. Okay, so for your exam, I'll try to increase the tolerance level so that even if you get very close answer, you will get the credit for that. Okay, I'll try to increase the tolerance level. So determine the sampling distribution of the sample mean of sample size 2. So now we need to determine the sampling distribution of sample size 2. So the mean will be same, 1.4. The only difference is the standard deviation. So the only difference is the standard deviation. So this one will be then 0.15, sorry, sample size 12. So this one will be then 0.15 divided by a square root of 12. So this is 0.0433. So this is 0.0433. So this is the correct answer. Yeah. Construct a graph of the normal population distribution. So construct the graph of the normal population distribution and 2 sampling distribution of brain weights. So it's the correct answer. So now we have to construct the normal curve for both of them. So now we can see the mean is 1.4, 1.4, 1.4. That's correct. So when the sample size is larger, the variability or spread will be smaller. So that's mean if this is the population mean, then for n equals to 3, yeah, that will be the sampling distribution for n equals to 3. And this one is the sampling distribution for n equals to 12. And you know that the variability for the sampling distribution will be smaller than the variability of the population distribution. So the first one, it shouldn't be correct. Here, the population distribution has less variability because they are all the data are very close to 1.4. So this is not correct. But here the population is spread widely. Then n equals to 3 has less variability, and n equals to 12 has the smallest variability. So this one should be the correct answer. Okay, so determine the percentage of all samples of 3 men that have mean brain weights within 0.1 kilogram of the population mean brain weight of 1.40. So here, determine the percentage of all samples. So here 1.40, and within 0.1 kilogram of the population mean. So within 0. So that's mean 0.1, and this is 1.4 minus 0.1. Okay, so since the population distribution is normally distributed, then the sample size for 3 men, that means sample size is 3. So we have to actually find the probability x bar less than equal, let me write it again. So for all 3 men, that's mean we need to consider the sample size n equals to 3. We have to find the probability of this 1.4 minus 0.1 x bar 1.4 plus 0.1.
Your sister really doesn't like me.
This should be 0.1. Okay. So that's mean we need to find the probability 1.4 minus 0.1. So that's mean 1.3, and x bar less than 1.5. So we have to calculate this probability. So how do we calculate this probability? So you have to first standardize this number 1.3. So how do you standardize? X bar minus mu and sigma over square root of n. So what is x bar here for sample size 3? The x bar is okay, so x bar is here 1.3. So this number is 1.3 minus mu is 1.4. And what is sigma? Sigma is this one, 0.0866 divided by square root of 3. Oh, I did mistake actually. This is already sigma by square root of n. So you do not need to divide it by square root of 3. So you have to just calculate this one. And for this number, you have to calculate 1.5 minus 1.4 divided by 0.0866. So you will get the z-score for this one, and you will get the z-score for this one. And from the z table, you can calculate the probability. Do you have any question? Is it clear, or do you have any question? Okay, so first you will calculate the z-score, then you will look at the z table, and you will get the probability. Okay, so I'm not going to calculate this one, just I'm putting the number 0, and let's check the results. Is giving wrong because 0 is not the correct answer. I am putting 0 to move forward. Okay. Okay, so you will get the probability 0.7518. So that means 75.18%. Okay. So now determine the percentage of all samples of 12 men. So now we will calculate the same probability when sample size is 12. So you have to calculate the same probability, but now the standard deviation will be different. It will be 0.0433. Okay, so let's move to the next question. So a variable of a population has mean mu and standard deviation sigma. So a population has a mean mu and standard deviation sigma. So for a large sample size n, so we have a large sample size which is n and complete pairs A through D. Okay, so approximately of all possible samples have means within sigma over square root of n. So that's mean sigma over square root of n is the
Why sometimes.
standard deviation for x bar, right? So within sigma over square root of n, that's mean within one standard deviation of the population mean. So that's mean you have to find the percentage within one standard deviation of the population mean. And so what do we know about the normal distribution? We know that within one standard deviation, approximately 68%, at least 68% data will be within one standard deviation. And approximately 95% will be within two standard deviation. And 99.7% will be within three standard deviations. So sigma over square root of n means one standard deviation. 2 times sigma over square root of means within two standard deviations. And 3 times sigma over square root of n means within three standard deviations. So that's why we have 68, 95, and 99.7%. Excuse me. Okay, a simple random sample is taken from a population and yields the following data for a variable of the population. So we have this data, find a point estimate of the population standard deviation. So that's mean, we are given a sample and we have to find the point estimate of the population standard deviation. So what is the point estimate of the population standard deviation? So if the population standard deviation is sigma, and if we do not know the population standard deviation, we calculate the sample standard deviation, right? And the sample standard deviation is the point estimate of the population standard deviation. So that's mean you have to calculate the sample standard deviation S, and that is the point estimate of the population standard deviation. So I'm not going to calculate this, but you have to, but I'm just putting 0 and move forward. Okay, so if you calculate, you will get the sample standard deviation is 9.9 for that question. Okay, so now find for the provided sample mean. So we have the sample mean, we have the sample size, and we have the population standard deviation, and we have to complete part A through C. So we have the sample mean, we have the sample mean x bar, which is 36, and we have n equals to 64, and we have sigma is 3. So we have to find the 95% confidence interval. So what is the 95% confidence interval? The 95% confidence interval is x bar plus minus t over t. Sorry. So here, now the question is, do we use z interval or t interval here? So what do you think? Should we use z interval or t interval here? Anyone? So which formula we should use in this case? T alpha over 2 times sigma over square root of n, or x bar plus minus so which formula we should use? Actually for t we do not use sigma, we use s. So the first one or the second one? Yes, x bar plus minus, that's correct. But I wrote down the formula for you. So this is the formula x bar plus minus t alpha over 2 s over s square root of n. This is the t interval, and z interval is x bar plus minus z alpha over 2 times sigma over s square root of n. So this is the z interval. So which one we should use? Should I use the first one or second one? So this is the first one, this is the first one, and this is the second one. Which one we should use in this case? Anyone? Second one, right? Because here sigma is known, we know the sigma value, and the sample size is 64, which is large, right? So that's why we can use the z interval. So you have to use this formula, x bar. So you know the x bar, which is 36, you know z alpha over 2. You have to calculate this one because we know the alpha is 0.5, here alpha is 0.5, so alpha over 2 is 0.025. You have to calculate the z alpha over 2, which is actually here 1.9. It will be, I think, 1.96. Yeah. Okay, then you have to plug in all the numbers in the second formula, this formula, and you will get two numbers, the lower limit of this confidence interval and the upper limit of this confidence interval. Okay, so clear all. I'm just putting 0 to move forward because I didn't do the calculation. So you will do the calculation, okay? And if you have question, you can ask me. Yeah, so you will get the lower limit is 35.25 and upper limit is 36.75. Okay, so identify and interpret the margin of error. So what is the margin of error E? This is the upper limit of the confidence interval minus the lower limit of the confidence interval. So that's been 36.75 minus 35.25. So this is the margin of error. So that's been 36.75 minus 35.25. So this is 1.5. So the margin of error is 1.5. Yeah, this is 1.5. Oh, this is not correct. Identify and interpret the margin of error. Okay, let me do it again. 36. Oh, I'm sorry, I did mistake. So margin of error is not the, this is the width of the confidence interval, right? Width of the confidence interval is, I did mistake here. Yeah, I'm sorry. And this is the width of the confidence interval. And margin of error is the width of the confidence interval divided by 2. So that's mean 1.5 divided by 2, this is 0.75. So it should be actually 0.75. So this is 0.75. Yeah, let me check the answer. Yeah, that's correct. Okay, so interpret the margin of error. So is the correct answer below. We can be 95% confident that the population mean mu is within the margin of error of the sample mean 36. That's not correct. We can be 95% confident that the any possible values of the variable is within margin of, we can be 95% confident the value of the variable within the margin of error of the, no. We can be 95% confident that the population mean is within the margin of error. I think this one should be correct answer. Yeah. Actually, the confidence interval says that we are 95% confidence that mu will be between these two numbers, x bar minus z alpha over 2 sigma over square root of n, and x bar plus z alpha over 2 sigma. That's when the population mean is within this margin of error from the sample mean. This is the sample mean and this is the margin of error. Okay, so express the endpoints of the confidence interval in terms of the point estimate and the margin of error. Okay, so now you need to write the confidence interval in terms of point estimate and margin of error. So the first number is the point estimate, which is the sample mean 36, and this number is the margin of error. So that means this is 0.75. Okay, so determine a 95% confidence interval for the mean cost mu. So we need to construct the 95% confidence interval. So this is similar question. So you have this number, the sample mean, and you have to construct the 95% confidence interval. Then you have to find the margin of error, and so I'm not going to solve this one. Okay, so in each part, assume that the population standard deviation is known. So we are assuming that the sigma is known here. Decide whether use the Z interval procedure to obtain a confidence interval for the population is reasonable. Explain your answer. So whether using Z interval is reasonable or not. If it is reasonable, then explain your answer. The sample data contains no outliers. The data has no outliers, and the variable under consideration is roughly normal. Sample size is 24. Okay, the idea is when there is no outliers, and if the distribution is roughly normal, and if the sample size is over 15, then we can use the interval. So that's mean the sample size is 24, which is over 15, so we can use the interval. So this is the correct answer. Okay, so let's move to the next part. The distribution of the variable under consideration is highly skewed, and the sample size is 20. So when the distribution is highly skewed and the sample size is not large, then we need to use different interval. The interval procedure is reasonable since sample size is over 15. This is not correct. Since the sample size is 15 and doesn't contain outliers, this is not correct because it is highly skewed. So that means it has some outliers. The interval procedure is not reasonable since the sample size is too small for a population that is far from normally distributed. Yeah, sample size is not too large and it is far from population distribution, right? This is highly skewed distribution. Okay, the sample data contain no outliers. There is no outliers. Sample size is 254, which is large, and the variable under consideration is far from being normally distributed. Excuse me. Okay, so if there is no outliers, and even though it is far from normal distribution, but the sample size is very large, 254, so we can use the Z interval. The Z interval procedure is reasonable since the sample size is more than 30, right? Yeah. Okay, a sample mean, sample size, population standard deviation, confidence interval are provided. So we have the confidence level. So we have X bar, which is 22. We have N sample size is 36, and sigma is 2, and alpha is 0.05 because the confidence level is 95%. So the first thing is use the one mean Z interval procedure to find a confidence interval. So you have to first find the confidence interval, X bar plus minus Z alpha over T times sigma over square root of N. So Z alpha over 2, Z 0.05 over 2. So that's mean Z 0.025, which is 1.95. Sorry, 1.96. You can find it from the table. So that's been, this is 22 plus minus 1.96 times sigma is 2 and square root of N. N is the sample size, which is 36. So now you need to just simplify these numbers and you will get the results. Okay, do you have any question? Okay, so I'm just putting 0 to move forward. because we didn't simplify, right? So I'm just putting 0 to move forward. So finally, you'll get 21.3 and 22.7. Obtain the margin of error. So how do you obtain the margin of error? This is the width divided by 2. So that's been 22.7 minus 21.3 divided by 2. So it will be then 22.7 minus 21.3 divided by 2. So 0.7. So it will be 0.7. So the answer is 0.7. What is the length of the confidence interval? Oh, okay. So I'm sorry. They didn't ask for the margin of error. They asked for the length of the confidence interval. That's the width of the confidence interval. So it will be just the difference of these two numbers. So this is actually 1.4. Yeah, I thought that they asked for margin of error, but they didn't ask for margin of error. They asked for the width of the confidence interval. So it will be 1.4. So obtain the margin of error by using the formula this one. Identify the critical value. So you have to identify the critical value from the table, which is 1.96 here because alpha is 0.5. Okay, so what is the margin of error obtained using the methods of PERD B and C? So the margin of error is z alpha over 2 times sigma over square root of n, which is 0.7. Okay, so this is similar type of question, only the difference is the data are different and the level of confidence is 95%. Sorry, 90%. So you have to find the z alpha over 2 for 95%. So I'm not going to solve this one. Move to the next question. So a 95% confidence interval of 18 months to 48.8 months has been found for the mean duration of imprisonment. Okay, so here we are given the confidence interval of a political prisoners of a certain country with chronic PTSD. We have to determine the margin of error. So we have the confidence interval. So we have to determine margin of error. Then it is the difference between the upper limit and lower limit divided by 2. So that's been 48.8 minus 18 divided by 2, which is 15.4 months. So the answer will be then 15.4 in this case. So the answer is 15.4. Okay. So explain the margin of error. It says that we are 95% confident that the maximum error made in estimation mu by x bar is found in part A, and minimum error made in estimating mu in part B, and one can be 95% confident that the interval at this month contain the mean a prisoner, the average duration of so the minimum error not the minimum, the maximum error. Yeah, I thought that B is the minimum maximum. Sorry, it will be the maximum error is the margin of error. So this is the correct answer. Yeah, the required sample size to have a margin of error 12 with a 99% confidence interval. So we want to have 99% confidence interval, and we need to find the sample size to have margin of error 12. So the margin of error is z alpha over 2 times sigma over square root of n. So n is then square of this. So this is the formula to find the sample size. So you have to calculate the z alpha over 2. In this case, I think this is 2.576. And sigma is sigma is given, which is the population standard deviation. And E is given, we want to have 12, the margin of error is 12. So we want to have this margin of error. Okay, so now you have to plug in all the numbers and you have to find the n, the sample size. Okay, so per D is find a 99% confidence interval for the mu. For part D, you have to find x bar plus minus z alpha over 2 times sigma over square root of n. So that's mean first find the z alpha over 2 and plug in all the numbers here and you will get the confidence interval. Do you have any question? Okay, so here our assumption is we'll be using one mean t interval. So that's mean the sigma is unknown and we are using the sample standard deviation for sigma. So interpret the lower confidence bound. So the interpretation is we are 100 times 1 minus alpha % confident, because the confidence level is 1 minus alpha time 100%. So this is the confidence level. So that's mean we are this percent confident that the population mean mu is, since this is the lower limit, so mu will be minimum of this. So mu will be at least this number. So mu will be at least this number, because this is the lower limit. And in case of upper limit, we are same percent confident that mu will be at most this number, maximum this number. So it will be at most this number. Okay, so here we are given the alpha value, we have to find the critical value. So for a T curve, complete pairs A through D. So determine the T value having area alpha to its right in terms of T alpha. Oh, I'm sorry. What happened? Okay. So let's move to the previous one. Oh, I did mistake actually. I moved to the first one, first problem. I'm sorry. So let me move real quick. I'm not sure how to go back to the problem very quick. Yeah, we did this one. Okay, so T value having area alpha to its right. So that's mean this one. So this is T alpha, and to its right means we are finding the probability T greater than T alpha. So the answer will be in this case. So since this is T value having area on the right tilt, so it will be T alpha. It will be positive. And when we are finding the area on the left, it should be negative T alpha, because for left tilt test, what we do, we say this is negative T alpha. So we find this area. So that's why it will be negative T alpha. And for two-tailed test, it will be negative T alpha over 2 and T alpha over 2, right? For two-tailed, negative T alpha over 2 and T alpha over 2. Okay, so now we need to construct the graph. So T alpha, and for the right tail T alpha, and this area is alpha. So this one is the correct. And for the part B, negative T alpha and area less than negative T alpha. So the area is alpha below this number, and this is negative T alpha. So this is the correct for lower tail. And for upper, for both tail, on the right we have T alpha over 2. The area will be alpha over 2. And on the left side, we have negative T alpha over 2, and the area will be alpha over 2. So which one should be correct? A is, this area is alpha, this is not correct. So this is also not correct. So this is also not. Okay, so that's where draw the graph. Illustrate part C, choose the correct graph below. Okay, so what is part C? Determine the two T values that divide the area under the curve into a middle on minus alpha. So in the middle, we have on minus alpha. Actually, this is not correct. This area should be, this is not alpha. It should be 1 minus alpha. Let's see what happened. Maybe this. Yeah, they said this is correct, but the way they constructed the graph, this is not correct actually. This is incorrect graph. Yeah, this is incorrect because I can show you. It should be actually like this. Negative T alpha over 2, T alpha over 2. This area should be 1 minus alpha, not alpha. This area is alpha over 2. This area is alpha over 2. Total is 1. The middle should be 1 minus alpha, but they say alpha. That's not correct actually. Yeah. This is wrong. Anyway. Okay, suppose that in a hypothesis test, the null hypothesis is in fact true. So we can make two type of error when we perform hypothesis test. We can make either type 1 error or type 2 error. Okay, so type 1 error is reject null when in fact null is true, and type 2 error is fail to reject null, in fact null is false. So here it says that the null hypothesis is true. So is there any chance to make type 1 error? Yes, there is a chance, because the type 1 is reject null when null is in fact true. So, and here the true fact is null is true. So there is a chance that we can make type 1 error. So yes, it is possible. And what is type 1 error? We are rejecting the null when null is true. So that's been the first one. And is it possible to make type 2? No, it is not possible, because when we make type 2 error, when the true fact is the null is false, but here null is true. So that's why there is no possibility of making type 2. So it is not possible because type 2 error is fail to reject null when null is false. So this is the correct answer. Okay, so suppose that in a hypothesis test, the null hypothesis is in fact false. When null is false, there is a chance that we can make type 2 error, but we cannot make any type 1 error in this case. So it is not possible because type 1 error is rejecting null when null is true. Is it possible to make type 2 error? Yes, it is possible to make type 2 error. A type 2 error is not rejecting the null when null is false. So this is the answer. Okay, so here we are given the mean length of imprisonment of a motor vehicle theft offenders in this country is 21.6 months. So we'll perform a hypothesis test to see whether this city differs from the national mean. So the null hypothesis is this one, and the alternative is this one. explain what it would mean to make a type on error. So make a type on error means rejecting null when null is true. So here the true fact is mu is 21.6 month. So that's mean the city mean is 21.6 month, but we are rejecting this fact. So that's mean a typo error would occur if in fact mu, no, this is not true. A typo error would occur. In fact, this is mu is 21.6, but the results of sampling fail to lead this conclusion that, okay, this is not true. So a typo error would occur if in fact this is true, but the data is leading to this conclusion. So the true fact is mu is 21.6, but the data is, or the results is saying that this is not. So this is typo error. So what is the type 2 error in this case? The type 2 error means the true fact is null is false. So that's mean mu is different from 21.6, but we fail to conclude that. So that's mean a type 2 error occur if in fact mu is, no, this is not true. A type 2 error would occur. In fact, this is correct, but the sample leads to conclusion this, then it will be correct decision, right? So if this is correct and the sample leads to the same decision, then that is correct decision. A type 2 error occur if in fact this is true, but it leads to, but it fails to lead this conclusion. Yeah, that is type 2 error. Okay, explain what it would mean to make a correct decision. The correct decision is when we'll fail to reject when mu is 21.6, or you can make correct decision in two ways. One way is our decision is fail to reject when mu is 21.6, and the other one is our decision is reject the null when mu is different from 21.6. Okay, so what is option A? A correct decision would, if this is this one and the result sampling leads to the rejection of that fact, you know, if mu is this and the results of sampling directly lead to the conclusion. Correct decision would occur if this is true fact, no, do not lead to rejection of that fact. Okay, yeah, that's correct. If mu is this one and the result sampling lead that conclusion, yeah, this is the correct answer, then it will be correct decision. Okay, so now suppose that the results of carrying out the hypothesis test led to a non-rejection of the null. So we do not reject the null. Classify that conclusion by error type or as a corrected decision if in fact mean length of the imprisonment for motor vehicle theft offenders in the city equal to the national mean. Okay, so the true fact is it is equal to the 21.6 and we are not rejecting. So that's when we made the correct decision. Yeah. And suppose that the results of carrying out the hypothesis test led to a non-rejection of the hypothesis, and classify the conclusion by error type if the offenders in the city differs from this one. Okay, so we didn't reject, we failed to reject null when null is false. So that's when this is type 2 error. Okay, so here the graph of the right portrays the decision criteria of a hypothesis test. So we have the graph, we have rejection region, we have non-rejection region, we have the critical value. So we have to determine the rejection region. When do we reject in this case? This is right tail test. So we reject when the test statistics is greater than equal 1.405. That's mean the z value is greater than 1.405 or equal to 1.405. So that's mean we reject when z is greater than equal this number. Yeah. So determine the non-rejection region. So we reject when z is greater than equal this one. So the non-rejection will be opposite of this one. So that's mean z is less than this number. this one. Okay, so determine the critical value. The critical value is this one, which divides the intra-normal curve into two area, rejection region and non-rejection region. So here, this number dividing the normal curve in the non-rejection and rejection region. So it will be then 1.405. Determine the significance level. So what is the significance level? This area is the level of significance, which is 0.08. So alpha is 0.08 here. So construct a graph that depicts your results from A to D. So we need to now construct a graph for this one. So that's mean you need to get this graph, exactly same graph. Non-rejection, no, this is not correct. This is not this graph. Non-rejection, no, this is not correct. Okay, so this part should be rejection, non-rejection. No, this is also not correct. Yeah, critical value, this one. This is rejection region. This is non-rejection region. So this is the correct answer. Yeah. This one should be the correct answer. Yes. Okay. So identify the hypothesis test as two-tailed, left-tailed, and right-tailed. So this is the right-tailed test, right? So this is very clear that this is right-tailed test. And the alternative will be that mu greater than mu zero. Yeah. So this is the answer then. Okay, so now we have the test statistics of a right-tailed test. You need to find the p-value. So we have this one. We have to find the probability of z greater than 2.39. So for right-tailed test, we find the probability z greater than. For left-tailed, we find the probability z greater than z observed. And for two-tailed, we find the probability 2 times z greater than absolute value of z observed. So we can find that this is 2.39. So we can find this probability from the table. So look at the table here. Let me clear the drawings. 2.39. So this is 2.3 and 9 is the last column. So 2.39 is 0.9916. And we are finding the probability greater than, so it will be then 1 minus 0.9916. So this is actually 0.0084. 0.0084. So the p-value is then round to 3 decimal places, so 0.008. Okay, so the p-value is provides, so alpha is 0.1%. Alpha is 1% here. So I'm sorry. So alpha is 1%. So that's been 0.01. And our p-value is 0.008. So which is less than. So p-value is smaller than the alpha value. So that's mean we reject the null hypothesis. So that's mean the data provide sufficient evidence to reject the null. So the data provides sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis because the p-value is less than the significance level. Yeah. Okay, the test statistics in a right-tailed test is the negative 1.30 and determine the p-value. Okay, so this p-value is for sure greater than 0.5 because this is right-tailed test and z is negative number. So the probability will be the probability of z greater than negative 1.30. So it will be greater than 0.5. So how do we find this one? Okay, so here 1.3. Where is 1.3? 1.3 is 1.3 is somewhere here. So this is 0.9082. I think this is 0.908. Yeah, 3 decimal places, so 0.908. But this is not correct. The people that whether determine the test statistics is right tail, z negative 1.30. So we need to find z greater than negative 1.3. The data provides sufficient evidence, the p-value. Okay, so look at the table again. 1.3, oh, 1.30 is this one, 0.9032. 0.9032. So 903.
Oh, geez.
Not 90.
Start up with I'm so tired.
Okay, the p-value doesn't
No,
provide
no,
evidence
kitty. Oh.
because it is too large. It is not small. It is greater than the
Can you go down there or no? Sure, fairly no.
failed to reject.
Oh, just a goose.
Okay, so we have 2 more minutes. And here you have to calculate the test statistics for Z test.
Thank you.
So that means Z observed will be
He's so small.
0 sigma over square root of n. So you have all the numbers. You have x bar 31 minus you have mu 0 35. You have sigma, which is 9 over square
Dude,
root
I
of
didn't get home till like
Now you need to just
2:15 from
minus
work.
1. That is
And
the
I did
test
8 a.m.
statistics. Okay, so I will stop here. And
Same,
if you have any
same.
question, you can ask. So do you have any question?
I'm so tired.